Okay, I'm assuming that since we theoretically have done this, you have theoretically done this, I am assuming that you have a sense of what the Pythagorean relationship is. Right? We explored it. You explored it with the online, hopefully you did, or you looked at we did together as well. And we looked at how the area of squares, if you attach squares to the side of a right triangle, then they are related that the area of the two smaller squares adds up to the area of the larger square. That's where we are right now. We looked at finding some missing sides and things. Whoa. What happened here? Oh, I don't know what happened here. Something very strange has happened there. Anyways, we looked at finding missing sides. Okay, we went through and looked at finding some missing sides here. If you know two sides of a triangle, you can find the missing one. If you know the two shorter sides, you can add the areas, or in other words, the squares of the lengths. And I'm just highlighting the wrong one here. You can add the areas or the squares of the lengths to find the other ones. If you know the long side and one of the short sides, you can subtract. You end up subtracting the areas to find the other one. So right now this is called applying. Okay, this is called applying the Pythagorean theorem, which means it's not going to say in this right triangle, it's not going to be like this. It's not going to say here's a right triangle, find S. It's going to say we have to take it to the next step here, which is here's a situation. A boat starts here and travels like that, and you know this distance, and you know that distance, so what's this distance here? It's not going to say, here's a triangle, find side C. You're applying it to real situations. If you know two lengths, you can find the third one using that Pythagorean relationship. So this Explorer, hopefully you got all the way through it. Maybe you didn't get all the way through it. In that situation, first of all, some of the language, maybe you haven't heard this expression before, but I'm assuming you probably have. If you say something traveling from one place to the other as the crow flies, that's an everyday expression to mean if you measure the distance straight to somewhere. If you measure the distance from your house to school as the crow flies, it means exactly that, a straight distance. Now, I'm imagining a crow doesn't fly perfectly straight, so I don't know why that ever became this expression. But if you could go perfectly straight from one to the other, that's what that is. And it says, of course, you can't walk that way because you're walking through people's houses and through walls and all that. To walk, you have to go that way. So this, first of all, is having you find out how far is it if the crow flew straight there? How far is that distance? And then it's saying how much shorter is that, okay, as compared to this? Or how far did Sam walk? All right. Now, what distance did Sam walk is probably a question you can answer already, I'm guessing. Okay. What distance did Sam walk? Well, you're given that, so probably that one you can already answer for yourself. If you walk this way, maybe I'm not reading it properly, but Sam walks, I'm going the wrong direction here. Sam walks like that, right? How far is it from the house to the school? Answer depends on whether you travel as Sam does or in a straight line. Sam travels 400 plus 600 or 1,000 meters, right? The crow is going to be shorter, right? Diagonally across there is going to be shorter than going down and across. It's longer that way. If you take one block, like if you take one city block like that, if you walk this way and this way, it's shorter than if you go, like that's a longer distance, right? Sorry, this is shorter than walking the 2 blocks. It's longer than walking 1 block to the side. So that's what we're looking at here. If you want to find this, hopefully you're okay enough with the Pythagorean relationship. I would call this C for crow. I would say let C equal distance crow flies. If you didn't do this, you should probably write it down, right? I would say that that's the distance that the crow flies. I want you to start by writing a Pythagorean relationship for this triangle. If you know that value and you know that value, but you don't know this one, you could start by saying, since it's a right triangle, then c squared has to be equal to 400 squared plus 600 squared. That's your starting equation. This is an equation, because it's got an equal sign in it here, based on the Pythagorean relationship for that triangle. That's your starting point. And then you want to find C. Write an equation. It actually says that right beside this in your book. Write an equation, then solve. To solve that, you need to simplify this side. You simplify that side by doing some of the arithmetic that needs to be done there. 400 to the second power is 160,000. 600 squared is 360,000. If you add those two together, I believe you get 520,000. So we've got c squared, or in other words, the area, not that you would be able to construct this huge area, but the area on that side, if I could draw a nice square there, is 5,200. That's the area on that side. If you want to find what c is, it is the square root of 520,000. If c squared is 520,000, c is the square root of that. You could write what it is as a decimal because it's hard to, that's exactly what it is, but it's not, you have to evaluate it as a number. If you have a calculator, you could easily do that. Has somebody already done that? I could do it up here. 700 and, if we do square root of, I think, did I put one too many in there? I did, didn't I? I put one too many zeros in there, right? 721. Depending on how accurate, I would say for this question, since it doesn't say, I would say 721 is accurate enough. 721 meters, roughly. Maybe it's better to write it down here and say an actual sentence answer. Approximately 721 meters. Okay, that's using the Pythagorean theorem. I'm hoping that you are able to do this. When you went through and looked at the reflect on your findings, this is asking you to think about what's involved here, what you did, how it applies to what's going on here. Explain how the distance the crow travels is related to the side lengths. This is basically asking you to, explain your method here, or how is this related to this? Since it's a right triangle, depending on what you wrote up here, since it's a right triangle, then the two shorter sides squared have to equal the longer side squared. Okay? Why is the path the crow takes from Sam's house difficult to measure? Well, you couldn't really, this way you could take a car or something to measure the distance, but this would be pretty difficult to do. Anyways, is there any questions? Things you noticed as you worked through that? I'm going to stop this and we're going to look at the examples for this, the two examples. So if you have not written anything down yet, put a title